All right. So here continuity from the left and the right. It's kind of like continuity in general, but we can this especially is true for like a piecewise function. So if it's continuous from the right, if the limit from the right equals the value of that function right at that point, and it's continuous from the left if the limit as x approaches a value from the left is equal to the value of the function at that particular point. So going back to like this last one that we looked at. So like for example here, this would be continuous from the left, right? Because it actually equals that value from the left. But from the right, it would not be continuous because the function at 3 is not the same as what the limit is, right? Like we got the limit was 4, but the function actually at 3, if you plugged in 3, because it's equal to at 3, that would be 5, right? Or -5, I think it was. All right. And just to show you graphically, this is the example here. So the function would be continuous from the left in this case, right? Because it exists at, the function at that point is the same as what the limit would be at that point. But from the right, it would not exist because the value of the function at that point is not the same as what it approaches from the right. Okay. So that's continuity from either side. So now let's talk about continuous intervals. So we did this before with some other questions when it said where is it continuous. So we want to state the intervals where it's continuous, and we kind of did that before, like I mentioned. So here what I would do is I would try to figure out where the zeros are in the denominator, because this is a rational function, and so those are going to be the places of possible discontinuity. So and rational functions don't always have a 0 in the bottom. They could have, like if you had x squared plus 1 in the bottom, that can never be 0, right? Because if you square a number, it'll be positive or at least 0. And if you add 1 to a number that's positive or 0, you're going to get a positive, right? You're not going to get a 0. So so there are values that don't equal 0 in the denominator. So anyway, so in the denominator here, I'm going to factor out this expression x squared plus 2x. I'm going to factor out an x, so it'll be x squared plus x times x plus 2, I should say. All right, and now I can see, okay, well, I'm going to have, when x equals 0, that's going to be a discontinuity, right? And that's actually an essential discontinuity, or we'll use the book term, so we'll use infinite, right? Discontinuity, because there's nothing that cancels out with x on top. And then the other one is that x equals -2, right? Take the opposite of this, because that'll make a 0. And so that's also going to be an infinite discontinuity, okay? All right, so the intervals at which it's continuous, well, it'll be from -infinity to 0, right? And then infinities always have parentheses next to them when you use interval notation. Now the 0, we got to ask ourselves, is it included or not? Well, since it's undefined, it's not going to be included, so we put a parentheses there, okay? But then we pick up on the other side of 0 because it's defined everywhere else, right? Except for -2, so it's going to go from 0 to -2, and since -2 is undefined, I'm going to put parentheses there as well, okay? And then it will go from -2 up to infinity, positive infinity, okay? So those are the intervals where it's continuous. You can say continuous on, okay? All right. Now let's take a look at this one. So here we have a square root. So square roots, their limitation is we can't have a negative underneath here, right? So basically we can say that 4 minus x squared has to be greater than or equal to 0. And so that this is basically what we can solve for to find the domain of this function, and which will be also help us with continuity. So so we know that this can be greater than or equal to 0 for it to exist, right? For it to be real at least. And so what I would do is I would add x to both sides, add x squared. And so we end up with 4 is greater than or equal to x squared. So then we can take the square root of both sides, right? And we get x greater than or equal to 2. Now the problem is that, remember, there's a plus or minus that we do, that we want to put out here, right? So it's really plus or minus 2, but the way it works with this inequality is that x has to be x actually has to be less than or equal to 2, right? Because if it was greater than 2, then it would be like 3. If I squared 3, I would get 4 minus 9, right? And that would be, so x has to be less than 2, but it has to be greater than or equal to negative 2, right? Because once again, if I put a negative 3 in square, I get positive 9, and 4 minus positive 9 is negative 5. So it has to be greater than negative 2, greater than or equal to negative 2, and less than or equal to positive 2. So it's actually this interval. And this is inequality notation. That's totally fine if you want to leave it like that, or you can put it in interval notation like this. Okay. All right, so negative 2 to 2, we put brackets there because we have the or equal to that is included, right? And the reason it's or equal to is because this can be 0, right? It's okay for it to be 0, so it's okay for it to equal 0. It just can't be less than 0, okay?